Imagine staring up at the night sky, a dazzling canvas of stars, galaxies, an endless wonder that makes the universe feel alive and infinite. But what if I told you there's a place out there, a colossal scar in space itself, where that brilliance just vanishes? A haunting void over 330 million light-years wide, so empty it defies everything we know about the cosmos. Stick around and smash that like button and subscribe, because this isn't just a gap, it's a cosmic mystery that could rewrite reality. Prepare yourselves. We begin. In 1981, a team of astronomers set out on what seemed like a routine cosmic mapping project, but what they uncovered would shake the foundations of how we view the universe's grand design. Led by a young Harvard researcher named Robert Kirshner, alongside his colleagues Brent Tully and Richard Fisher, they were delving into a redshift survey, a technique that measures how light from distant galaxies stretches toward the red end of the spectrum as the universe expands, essentially acting like a cosmic speedometer to gauge distances and speeds across vast reaches of space. Armed with newfangled technology, like charge-coupled device detectors on telescopes that could capture fainter objects than ever before, they targeted the constellation known as Boötes, a herdsman figure in the night sky that had long been a familiar backdrop for stargazers. But as their data poured in from the Kitt Peak National Observatory in Arizona, something utterly bizarre began to emerge. Not a cluster of bright galaxies as expected in that direction, but a glaring absence, a yawning gap, where the redshift numbers showed galaxies should have been clustered thickly. Kirshner and his team sifted through thousands of photographic plates, each one a snapshot of the heavens, exposing points of light that represented entire galaxies, millions or billions of light years away. And there it was, a spherical region spanning hundreds of millions of light years, where the density of these points dropped to almost nothing. They double-checked their instruments, recalibrated their calculations, because in a universe governed by the cosmological principle that matter should be evenly spread on large scales, this kind of emptiness shouldn't exist. Yet the numbers didn't lie. By the time they published their findings in the astrophysical journal Letters, they had mapped out a void roughly 330 million light-years across, containing just a scant 60 galaxies, where statistical models predicted tens of thousands. The discovery hit like a thunderbolt in the astronomy community, sparking debates that echoed through conferences and papers for years, because it wasn't just an empty patch. It was a challenge to the smooth, uniform picture of the cosmos painted by the Big Bang Theory. Kirshner himself later reflected in interviews how the void felt like stumbling upon a hidden room in a house you thought you knew, inside out, prompting him to coin the term Boötes Void for this eerie expanse, drawing from the constellation's name to give it an almost mythical ring. And as word spread, other scientists rushed to verify the data using additional surveys from observatories around the world, confirming the void's existence with even sharper precision through improved redshift measurements that revealed its clean spherical boundaries, almost like a bubble blown in the fabric of space. What made the revelation so gripping was the sheer improbability in the cosmic web model that astronomers were piecing together at the time. The universe resembled a frothy sponge with dense filaments of galaxies threading through walls and nodes, separated by smaller voids of maybe 30 to 100 million light-years. But this one dwarfed them all. Its underdensity factor of about 100 times lower than average, meaning for every cubic megaparsec of volume, it held a fraction of the expected matter. The team had been inspired by earlier work, like the CFA survey, the Center for Astrophysics Redshift project, that was mapping nearby galaxies. But Boötes pushed the boundaries further, requiring them to probe deeper into the northern sky, where previous efforts had skimmed the surface. Kirshner's persistence paid off when they identified those isolated galaxies within, dubbing them island galaxies, lonely outposts adrift in the dark. each one a potential survivor of some primordial scarcity. And as they analyzed the redshifts, they noticed how these galaxies were receding at speeds consistent with the void's position, about 700 million light-years from Earth, placing it squarely in the realm of large-scale structure. The discovery ignited a flurry of theoretical work, with theorists scrambling to explain how such a massive underdensity could form without violating general relativity's predictions for gravitational collapse. Some pointed to quantum fluctuations in the early universe amplified by inflation, tiny ripples in the density that grew into vast basins over billions of years, while others speculated on topological defects, like cosmic strings or domain walls from phase transitions, though those ideas faded as observations refined. But the real thrill came from the human element. Kirshner recounting in his book Extragalactic Astronomy how the late nights poring over data felt like detective work, chasing clues across the sky, and the moment they realized the void's scale, it was as if the universe had whispered a secret, one that hinted at hidden complexities in its architecture. Fast forward to follow-up observations in the 1980s and 90s, using the Hubble Space Telescope and ground-based arrays like the Very Large Array. Astronomers peeled back more layers, finding faint traces of gas clouds or dwarf galaxies that might have evaded the initial survey. Yet even these additions couldn't fill the void's profound emptiness, reinforcing its status as a supervoid, a term that entered the lexicon thanks to this find. And it wasn't long before popular media latched on. Articles in Scientific American and documentaries portraying it as the Great Nothing, a place where the laws of star formation seemed to falter, drawing parallels to science fiction voids that swallow ships. But grounded in hard science, the discovery's impact rippled into cosmology, influencing models of the cosmic microwave background, where cold spots might correlate with distant supervoids, and even touching on dark matter distributions, since the void's low galaxy count suggested a corresponding deficit in invisible mass. Kirshner and team had unwittingly opened a Pandora's box of questions. Why here in Boötes? Why so spherical? And what does it say about the universe's lumpiness on scales we can barely fathom? As redshift technology evolved with fiber optic spectrographs in the 2000s, surveys like the Sloan Digital Sky Survey revisited the region, mapping over 1 million galaxies and outlining the void with unprecedented clarity, revealing its edges where filaments of denser matter abruptly transition into the sparse interior, like a cosmic shoreline. And in those mappings, the surprise deepened, because the void wasn't irregular like most, but remarkably uniform, prompting studies on void statistics and how rare events like this fit into lambda cold dark matter simulations, where such structures emerge from initial conditions seeded by primordial perturbations. Yet even supercomputer runs struggled to produce anything quite as extreme without tweaking parameters, leading some to propose modifications to inflation models, or even multiverse ideas, where our universe's constants allow for such anomalies. The personal stories behind the discovery added layers of intrigue, with Kirshner collaborating with international teams, including Soviet astronomers during the Cold War's thaw, sharing data plates across borders to corroborate findings, and young postdocs, like Augustus Oemler, contributing spectral analyses that nailed down the void's redshift range from 0.1 to 0.3, translating to distances that boggled the mind. The emotional weight hit home when they presented at the American Astronomical Society meetings, facing skepticism from veterans who clung to the uniformity dogma. But the data won out, cementing Boötes as a landmark. And as decades passed, the void became a touchstone for education, inspiring curricula on large-scale structure and even art installations depicting its silence. But back to that pivotal 1981, the team's eureka moment came during a routine plotting session, when the galaxy counts on their charts plummeted, revealing the hole, and in that instant, the universe felt less predictable, more alive with surprises, pushing the boundaries of what we thought possible, and setting the stage for endless exploration. Because if a void this grand could hide in plain sight, what else lurks in the shadows of the cosmos, waiting to be uncovered by the next curious mind with a telescope and a question? The discovery didn't just map a blank spot, it redrew the map of reality itself, inviting us to stare into the abyss and wonder what stares back, with each new redshift measurement adding to the tale of how emptiness became one of astronomy's greatest enigmas, forever altering our gaze toward the stars. And in the years since, as detectors grew more sensitive and surveys more comprehensive, the void's contours sharpened. But its mystery only deepened, a testament to the thrill of that original find, where science meets the unknown in the heart of Boötes, and the story of its unveiling continues to captivate, reminding us that discovery often begins with noticing what's missing. In a universe full of light, the shadows hold the real power to illuminate, and so the legacy of Kirshner and his team's bold venture endures, a beacon for future astronomers, charting the uncharted, where every empty space promises a fuller understanding of the whole. But let's delve deeper into the mechanics of that survey. How they chose Boötes as their hunting ground stemmed from its position in the northern celestial hemisphere, accessible from northern observatories, and its proximity to known clusters like the Coma cluster, which they hoped would provide contrast. Yet instead of dense fields, the void loomed. Their methodology involved measuring radial velocities for objects down to magnitude 22, faint enough to reach out to billions of light years, using the 4-meter telescope at Kitt Peak. And as spectra accumulated, the redshift histograms showed a stark depletion between certain velocity shells, confirming the void's three-dimensional nature, not a projection effect, but a real volume deficit. This rigor ensured the findings' credibility, quelling doubts and spawning subfields like void cosmology, where structures like Boötes test theories of structure formation, and even influencing dark energy probes. Since voids expand faster in accelerating universes, their sizes offering metrics for the lambda parameter, approximately 0.7. But the human drama shone through in anecdotes, like Kirshner joking over coffee about the void being the universe's way of saying take a break, or the late-night calls between collaborators, debating if it was an artifact of incomplete sampling. Yet persistence prevailed, and by 1983, follow-up papers detailed the void's homogeneity, with galaxy underdensities consistent across slices, fueling simulations that modeled void evolution from Gaussian random fields. Initial density contrasts of order 10 to the -5 growing via Jeans instability into the behemoths we see, and in Boötes, that growth hit an extreme, perhaps due to a rare alignment of fluctuations, akin to winning a cosmic lottery, but one with profound implications, challenging the Harrison-Zeldovich spectrum of primordial perturbations, or suggesting non-Gaussianities from exotic inflation, like curvaton models or modulated reheating. Though standard cosmology suffices for most, the discovery's ripple effects touched philosophy too, echoing Lucretius's atomic voids or Pascal's infinite spaces that terrify. But scientifically, it bolstered the inhomogeneous universe models, like those by Ellis and others, where local voids affect global averages. And for Boötes specifically, its position at right ascension, 14 hours and declination 48 degrees, made it a prime target for ongoing monitoring with instruments like the James Webb Space Telescope, which in recent years imaged infrared signatures of dust-obscured galaxies within, hinting at hidden populations that might populate the void more than thought, yet still far below expectations, keeping the enigma alive. The team's original paper, titled "A Million Cubic Megaparsec Void in Boötes," captured the awe, describing the region as remarkably underdense, and since then, over 40 years of scrutiny have only amplified the wonder, with citizen science projects like Galaxies Zoo crowdsourcing classifications of void galaxies, revealing morphological peculiarities like higher fractions of early type galaxies, possibly due to less merger activity in low-density environments, and spectroscopic follow-ups showing lower metallicities, suggesting isolated evolution, all tracing back to that fateful survey where curiosity met cosmos and emptiness spoke volumes. So as we reflect on the discovery, it's clear that Kirshner and crew didn't just find a hole. They unearthed a portal to deeper questions about homogeneity, hierarchy, and the hidden hand shaping the heavens. And, in that sense, the Boötes Void's birth in 1981 marks not an end, but an eternal beginning for exploration, where science thrives on the surprises of space, and every void filled with potential stories untold, extending our journey into the heart of what makes the universe tick, with the discovery as the spark that lit the fuse, burning bright through decades of inquiry, forever hooking us on the hunt for more. When trying to grasp the sheer scale of the Boötes Void, the mind must surrender its usual reference points and venture far beyond everyday imagination. For this is not simply an empty patch in space. It is a vast, spherical expanse of almost nothingness that dwarfs anything humanity has ever mapped or even conceived. Positioned in the celestial skies near the constellation Boötes, the void sits roughly 700 million light-years from Earth, yet its reach extends for 330 million light-years across, an immense diameter that instantaneously swallows up familiar landmarks like entire galactic clusters without a trace. To appreciate what this truly means, picture the Milky Way, our home galaxy, which stretches about 100,000 light-years wide, a sprawling disk of stars and gas that has taken billions of years to form. And now envision lining up over 3,000 full-sized Milky Ways, end to end, just to span the length of this single cavernous space, and still having room left over, because the void's boundaries stretch even further. Imagine the planet Earth, a modest 12,700 kilometers across, an extent that an airplane could circle in less than 2 days, a world where entire civilizations rise and fall within the blink of a cosmic eye. Now multiply that by such unfathomable orders of distance that casual comparison collapses, and recognize that the fastest thing known, light, which races across nearly 300,000 kilometers every second, still takes over 300 million years to travel from one side of the Boötes Void to the other. Not 300 seconds, not 300 days, or even 300 years, but 300 million years. Meaning, this void is so gigantic that if you launched a spacecraft at light speed to traverse it, generations would pass and eons would unfold before you ever reached the far edge. Civilizations could evolve from single cells to spacefaring societies and fade away entirely, all while your journey barely covers a fraction of the distance. Now zoom out again and realize that in cosmic terms, this one void alone accounts for nearly 0.3% of the entire observable universe's volume, a slice so large it's akin to erasing an entire continent from the map of the Earth, or better yet, imagining the whole solar system as a mere grain of sand lost in an endless desert that spans horizons beyond sight. And yet, despite filling this enormous space with such dominance, the number of galaxies within the Boötes Void is astonishingly tiny. Only about 60 scattered islands dot the emptiness, where thousands and thousands should be clustered. Statistical models tell astronomers there ought to be at least 2,000 galaxies in an expanse that size, perhaps as many as 10,000 or even more, depending on the density fluctuations, and yet the void holds just a handful. Sometimes compared to a desert in the heart of a forest, it stands as not merely the largest, but one of the most sharply defined supervoids ever identified in the known universe, a title it shares with a few others, like the Eridanus Supervoid, but even those pale in comparison to its clean, bubble-like precision. To see its magnitude in star charts or cosmic web simulations, one finds a huge circular region surrounded by tangled threads and clusters. These threads are the filaments of galaxies that make up the backbone of the universe's foam, vast cosmic highways where matter flows and clusters form, while the Boötes Void forms the unmistakable bubble, its edges demarcated by nearby superclusters like Ursa Major, Hercules, and Corona Borealis, which loom as dense walls just beyond the boundary. In 3 dimensions, the void's border is remarkably clean, unlike most voids which are fuzzy and irregular. Over volumes of almost 236,000 megaparsecs cubed, this emptiness dominates, a megaparsec itself being over 3 million light-years. So stacking those volumes evokes a sense of infinity layered upon infinity. Now imagine living on an outpost galaxy, marooned in that void, looking up into a night sky that is not ablaze with stars or glowing nebulae, but is dark and silent. The nearest galaxy may lie millions of light-years away, making cosmic solitude more profound than anything familiar. So profound that astronomers speculate entire civilizations could languish for eternity, never certain the universe even exists beyond their own isolated speck, perhaps developing philosophies of absolute uniqueness or myths of a singular creation, unaware of the grand web just beyond their reach. By contrast, on Earth, a telescope reveals the Milky Way, Andromeda, and dozens of nearby galaxies as testament to the richness of our cosmic neighborhood. The local group alone hosts over 50 galaxies within a mere 3 million light-years, a bustling community where gravitational dances pull neighbors closer over time. The Boötes Void stands as a challenge to the cosmological principle, which posits that matter spreads uniformly on the largest scales, because the void's size is not just greater, but almost tenfold beyond what mainstream science assumed possible before its discovery. It is a place that should not exist according to chance alone, and yet it does. A great nothing, marking the rhythm of cosmic evolution. Others have compared this expanse to an immense football field, with the Milky Way reduced to a humble coin at the center, or even to the entire observable universe itself, which spans 93 billion light-years across, making the void about 0.35% of that total diameter. A tiny fraction on paper, but a colossal absence. When considering the missing matter, it is so vast that if our galaxy were situated at its heart, observers might not even discover another galaxy for generations. Some estimates predict that, if humanity had originated there, we may have only realized other galaxies existed in the 1960s, with the advent of modern telescopes like Palomar. Prior to that, we would have looked into darkness, inventing stories about the emptiness, perhaps attributing it to divine will or an eternal night. Cosmological simulations attempt to reproduce voids this extreme, but rarely succeed unless parameters are stretched, making the Boötes Void scale not just an outlier, but a rare cosmic lottery, possibly resulting from the merger of smaller voids, like soap bubbles combining into one massive sphere, or the absence of dark matter's gravitational grip, which normally seeds galaxy formation. In the end, the Boötes Void's size is not merely a number or a trivial measurement. It is a confrontation with the limits of human comprehension, a gateway into the raw wonder and uncertainty at the heart of cosmic science, rendering all our measurements and worldly constructs humble by comparison, and beckoning us into the ultimate abyss, where scale itself becomes the central mystery. But to truly unpack this enormity, consider the journey light undertakes. For every photon that escapes a star in one of those 60 lonely galaxies must cross unimaginable gulfs, traveling not just through vacuum, but through the expanding fabric of space itself, stretched by dark energy, the force that accelerates the universe's growth. In the Boötes Void, this expansion might play out unchecked, with fewer galaxies to slow it via gravity, potentially making the void grow even larger over time. Some models suggest it could swell to encompass even more territory in the coming billions of years, merging with adjacent empties to form ever grander absences. Now think about the volume, not just the diameter. The sphere's interior holds a space equivalent to billions upon billions of solar systems, stacked like books in an infinite library, yet barren, a testament to how the early universe's quantum ripples Those infinitesimal variations in density from the Big Bang can amplify into such cathedrals of nothing, in contrast to denser regions like the Virgo supercluster, which packs thousands of galaxies into a mere 110 million light-years. The void's sparseness highlights the universe's Swiss cheese nature, where voids claim 80% of the volume, filaments and walls the rest. But Boötes takes that to an extreme. Its underdensity factor of 100, meaning it has 1% the expected matter, a statistical fluke so improbable it borders on the miraculous. Astronomers like Robert Kirshner, who first spotted it, marveled at how this supervoid fits into the lambda cold dark matter model, where structure forms from primordial seeds. Yet extremes like this push the model's edges, prompting tweaks to inflation theory or even speculation about modified gravity. Imagine charting it with today's tools: the James Webb Space Telescope peering infrared through cosmic dust to hunt for hidden dwarfs, or the Euclid mission mapping billions of galaxies to outline voids in exquisite detail, revealing Boötes as a near-perfect sphere, its center at right ascension, 14 hours, 50 minutes, and declination, 46 degrees, a coordinate that points to this cosmic oddity from our vantage. And in those maps, the void appears as a dark circle amid the glowing web, a hole in the fabric that invites questions about the universe's topology. Is it flat, curved, or riddled with such anomalies that hint at multiverse bubbles, where our patch of reality brushes against emptier realms? The scale also evokes philosophical awe, echoing ancient voids in Greek atomism or modern existential voids in human experience. But here it's literal, a place where potential for life or matter fizzles out, yet perhaps teeming with quantum foam, virtual particles flickering in and out, the true underbelly of emptiness. To scale it against human endeavors, consider Voyager 1, humanity's farthest probe, which after 47 years has covered a mere 0.001 light-years, a snail's pace against the void's breadth, or the entire human history, spanning just 10,000 years, a mere instant in the 300 million year crossing, underscoring our fragility, yet also our curiosity that dares to name and study such immensities. Comparisons to other voids amplify its uniqueness. The Eridanus supervoid, linked to the cosmic microwave background's cold spot, stretches up to 1 billion light-years, but lacks Boötes' sharp definition, blending fuzzily, while the local hole, or KBC void, which may encompass us at 2 billion light-years wide, is milder, a gentle underdensity rather than stark absence. Boötes reigns as the poster child of supervoids. Its 60 galaxies, like lighthouses in fog, isolated spirals, like MCG, +01, -02, -015, imaged by Hubble as a lone sentinel, amid background specks, and from there the night sky would be a velvet black, no Milky Way band, no satellite galaxies, just pinpricks from afar, shaping any observer's worldview into one of profound aloneness. Yet this scale also offers scientific gold. Voids like Boötes probe dark energy's influence, as their freer expansion rates calibrate the universe's acceleration, helping resolve tensions like the Hubble constant discrepancy, where measurements clash between early and late universe data. Perhaps our local void skews perceptions, making Boötes a benchmark for such tests. In popular culture, its vastness fuels speculation, from alien megastructures to simulation glitches, but science grounds it in natural evolution, smaller voids coalescing over time, gravity failing to clump matter in underdense zones, leaving this legacy of emptiness. And as we expand our surveys with the Vera C. Rubin Observatory or future space arrays, we'll uncover more such behemoths. But Boötes remains the icon, its scale a humbling reminder that the universe thrives on contrast, where fullness defines the voids as much as voids frame the fullness, inviting endless wonder at how something so empty can reveal so much about everything. In this grand theater of space, the Boötes Void steals the show, not with light, but with the audacity of its absence, a silent giant that reshapes our cosmic narrative, one light year at a time. And in pondering its breadth, we touch the infinite, feeling small yet connected to the grand design that birthed such wonders from the Big Bang's first breath, where chaos birthed order and voids alike, forever expanding into the unknown. Emptiness in the Boötes Void is not just a matter of missing light or a simple absence of celestial bodies. It is the ultimate expression of cosmic loneliness, a staggering testament to the forces that shape the large-scale structure of the universe, and left behind an almost pure canvas onto which only a few tiny galaxies were ever painted. And the more we peer into its shadowy depths, the more this void becomes a place where existence itself seems to thin out, stretching the mind and spirit towards a realm of sheer isolation. For within this sphere of space, measuring nearly 330 million light-years in diameter, the number of galaxies documented is about 60, a number that not only disappoints by comparison, since models based on average cosmic density expect between 2,000 and 10,000 galaxies in such a volume, but also inspires awe, since these lonely islands are curiously confined to a narrow, tube-shaped corridor running through the middle of the void, as if a faint vestige of cosmic structure survived the universe's process of galactic clustering. The gaps between these galaxies can reach tens of millions of light-years, which is so immense that from Earth's perspective, the Milky Way's closest neighbors, such as the Magellanic Clouds and Andromeda, would disappear entirely, leaving only a void. And inside Boötes, the emptiness is not only spatial but existential. Astronomers have mapped the region using redshift surveys, plots of brightness and distance that make visible the profound scarcity. And these efforts reveal galaxies that are dim, small, and often starved of star-forming material, where atomic hydrogen clouds are less abundant than in typical spiral galaxies elsewhere. A result confirmed by observations from the Green Bank telescope and the Combined Array for Research in Millimeter Astronomy. These galaxies rotate slowly, a reflection of their isolation and lack of mergers, spinning disks at 256 kilometers per second, compared to rates over 300 in more populous environments. And their masses are measured at levels far below what is typical, with the hydrogen mass of Boötes galaxies hovering around 3.1 times 10 to the ninth solar masses, and their stellar content about 21.5 times 10 to the ninth solar masses, drawing out billions of years of slow, gentle evolution that is rarely disrupted by outside forces. Star formation here is not a bustling dance, but a quiet simmer. Gas depletion, times stretch for billions of years, and the most metallic elements, those forged in the hearts of massive stars and spread by supernovae, are rare, indicating that the cycle of cosmic recycling is weak. Some morphologies seen through the James Webb Space Telescope hint at histories that lack violence, with more elliptical shapes and smoother disks than the turbulent galaxies found in filaments and clusters. All these physical markers point to an evolutionary path defined by solitude, and the architecture of this cosmic emptiness invites theorists to probe its origins. Most now agree that the Boötes Void was formed through the merger of smaller voids, like soap bubbles popping into one, possibly leaving behind only the long, cylindrical passage of that faint filament that hosts the surviving galaxies. The surrounding region, bordered by dense superclusters like Hercules and Ursa Major, is sharply defined, making this void not only extreme in size, but in clarity. And, as maps based on surveys like the Sloan Digital Sky Survey have shown, this boundary is a nearly perfect sphere with dramatic transitions between absence and presence. It is in these boundaries that astronomers have searched for clues about the behavior of galaxies on the edge of emptiness, asking whether their orbits flow towards or away from the void, and whether dark matter flows around the region like a stone in a river, even beyond galaxy counts. The void is an important test case for theories about universe formation under the lambda-cold dark matter model, in which quantum fluctuations and rapid inflation after the Big Bang can create zones of overdensity and underdensity so profound that galaxies simply never gain enough gravity to collapse and form. And while these explain Boötes in part, computer models still struggle to create such extreme emptiness without tweaking parameters. Some speculate that exotic physics, phases of the early universe, varying properties of dark energy, or even relics of hypothetical massive objects may be necessary to understand how the void's central emptiness lasted billions of years. For life appearing in such a region, the consequences are almost unimaginable. Civilizations could emerge never knowing there was more, never registering redshifts or cosmic expansion. Their conceptions of reality, internally focused, devoid of context, perhaps developing science based only on local phenomena, and never suspecting the grand web of billions upon billions of galaxies that exist just out of reach. And if they ever manage to look out, the first realization of others could only happen with the development of technology so advanced it pierces the void from one end to the next, an effort that on Earth took until the 20th century with the construction of 100-inch telescopes or radio arrays. The psychological implication of this isolation is profound, as the emptiness within Boötes Void is not just spatial, it is also philosophical, a challenge to human understanding, an invitation to ask questions about the meaning and possibility of existence in a universe where absence is as important as presence. This emptiness has shaped everything from cosmological models to speculative fiction, serving as the ultimate setting for stories of solitude and forgotten worlds. But in real science, the void is a laboratory for studying structure formation, dark energy, and the behavior of isolated systems, because only here do we see the undisturbed effects of expansion. Only here do we witness star formation, slowed to a crawl, and physical interactions stretched to the limits of isolation. The void also teaches astronomers about the boundaries between structure and chaos. For while the rest of the universe is clumpy, galaxies clustering in groups, groups clustering in clusters, clusters forming superclusters, the Boötes Void is the mirror, the other side of that architecture, where space is so underpopulated that new galaxies may never form, and the galaxies that are present evolve in near-perfect tranquility, and yet even emptiness speaks in signals, in the faint glow of isolated radio emissions, the slow turn of hydrogen clouds, the soft spiral arms of galaxies, left untouched for eons. The Boötes Void is thus not a failure of creation, but an affirmation of the universe's diversity, a place where the rules of connectivity and isolation are both followed and broken. And as we study it, measuring, mapping, and imagining, we touch upon one of the most haunting mysteries in all of astronomy, that silence and emptiness can themselves become the central characters in the epic story of the cosmos, hinting that what we do not see might just be as important as what we do, and that in the end, the heart of the Boötes Void is not just empty, it is quietly, eternally alive with possibility. Deep in the swirling eddies of misinformation that swirl around cosmic wonders, the Boötes Void stands as one of the most misunderstood enigmas in astronomy, often cloaked in dramatic myths and viral illusions that transform a profound scientific curiosity into a sensationalized specter of the unknown. But peeling back these layers reveals not a portal to oblivion or an alien-engineered abyss, but a natural feature of the universe's grand architecture. And it all begins with that haunting image you've likely encountered. A stark black circle against a starry backdrop, sprinkled with a few defiant pinpricks of light, captioned as the Boötes Void, a gaping maw where existence forgot to fill the space, shared across social media platforms and science forums with breathless warnings about the emptiness staring back. Yet this picture is nothing of the sort. It's actually Barnard 68, a dark nebula nestled within our own Milky Way galaxy, about 400 light-years away in the constellation Ophiuchus, a dense cloud of interstellar dust and gas that blocks the starlight from behind it like a cosmic curtain, creating the illusion of perfect blackness, but far from being a void in the large-scale structure of the universe. This nebula is a bustling nursery, where new stars are quietly incubating, its apparent emptiness merely a shadow play of absorption, not true absence, and the misconception spreads because visuals demand drama, turning a local oddity into the poster child for the Boötes Void's supposed horror. When in reality, the Boötes Void can't be photographed that way at all. It's not a two-dimensional hole in the sky you peer through with a telescope, but a three-dimensional underdensity spanning 330 million light-years, discovered not by imaging, but by painstaking redshift surveys that measure the recession of galaxies, revealing vast gaps in the cosmic web, where matter failed to cluster. No neat circular patch visible to the eye, just a statistical silence in the data. And this mix-up isn't harmless. It erodes trust in real science, luring people into believing the void is a tangible darkness you could stumble into, like a black hole's event horizon. But black holes are points of immense gravity, warping space-time, sucking in light and matter, whereas the Boötes Void exerts almost no pull, its emptiness allowing space to expand freely. Under dark energy's influence, a gentle dilution rather than a devouring force. Another persistent myth paints the void as a tear in reality, a wound inflicted by some cataclysmic event, perhaps a collision of universes, or a burst of exotic energy that erased everything within, evoking images of a fractured cosmos leaking into nothingness. But astronomers like Robert Kirshner, who first mapped it in 1981, explain it as a natural outcome of the Big Bang's aftermath, where tiny quantum fluctuations in the early universe's density were amplified by cosmic inflation, creating regions of slight underdensity that gravity never reclaimed, evolving over billions of years into supervoids through the coalescence of smaller empty pockets, like bubbles merging in a cosmic foam. No dramatic rupture, just the universe's uneven settling, and the idea of it being perfectly empty fuels wild speculation, with some claiming 0 galaxies inside, a total vacuum of existence. But surveys have identified about 60, clustered in a faint cylindrical filament, threading the center, isolated spirals and ellipticals like CG 910 or MCG +01 -02 -015, their light reaching us after 700 million years of travel, proving it's underdense, not devoid, a factor of about 100 below average cosmic norms, where 2,000 to 10,000 galaxies should thrive. Yet these survivors whisper of resilience, not annihilation. And then there's the alien conspiracy angle, popularized in online forums and fringe documentaries, suggesting the void hides a massive Dyson sphere, or a cloaked megastructure built by an advanced civilization to harvest all energy, rendering the region invisible, or worse, that it's a deliberate quarantine zone, a cosmic no man's land where something dangerous was sealed away, perhaps a failed experiment or a predatory entity. But this stems from a misunderstanding of detectability. The void's galaxies are faint and distant, challenging even the James Webb Space Telescope to spot hidden dwarfs, but no evidence of artificial signals or anomalous infrared excesses points to extraterrestrials. Instead, radio and X-ray observations show natural processes like slow star formation in gas-poor environments, and the void's position in Boötes, a constellation long observed by ancient cultures, without hint of anomaly, underscores its ordinary origins, not a sci-fi plot twist. Even the notion that it's the largest structure in the universe gets twisted, some calling it a hole bigger than our observable cosmos. But at 330 million light-years across, it's a mere speck against the 93 billion light-year diameter of what we can see, one of several supervoids, like Eridanus or the local hole, though uniquely spherical and sharp-edged, bordered by superclusters such as Hercules and Ursa Major, and the myth of it violating the cosmological principle that the universe should look uniform on large scales, ignores how voids are predicted by the lambda cold dark matter model. Statistical flukes in an otherwise homogeneous expanse, rarer than average, but essential to the web-like structure, where filaments hold 80% of galaxies in 20% of the volume, leaving voids to claim the rest. And popular media amplifies these errors, with headlines screaming about a great nothing that shouldn't exist, fueling doomsday fears or simulation theories, where the void is a rendering glitch in our reality's code. Programmers forgetting to populate a sector, but simulations on supercomputers routinely produce similar voids from initial conditions. No glitches needed, just the math of gravity and expansion, and the emotional pull of these misconceptions lies in our fear of the unknown, projecting human voids, loneliness, loss, onto cosmic scales, imagining the Boötes Void as a graveyard of vanished galaxies, destroyed by some unseen force, when it's more like a quiet suburb the universe skipped, matter flowing to denser neighborhoods. And correcting these tales requires diving into the data, like the Sloan Digital Sky Survey's maps, showing the void as a clear bubble amid glowing threads, or spectroscopic studies revealing the island galaxy's peculiar evolution, lower metallicities from fewer supernovae, compact hydrogen disks rotating at 256 kilometers per second, all natural markers of isolation, not malice. And as telescopes advance, like the upcoming Vera C. Rubin Observatory, scanning billions of objects, will refine the count, perhaps adding faint interlopers, but the core truth endures. The Boötes Void is no monster, no mistake, but a beautiful anomaly, a reminder that science thrives on dispelling shadows with light, turning myths into milestones. And in exposing these misconceptions, we not only honor the void's real majesty, but invite a deeper appreciation for the universe's intricate, indifferent balance, where emptiness is just another thread in the tapestry, woven from the same stuff as stars, challenging us to see beyond the illusions and embrace the wonder of what truly is. The formation of cosmic voids, and of the Boötes Void in particular, is a saga that stretches back to the earliest flickers of time, before galaxies, before stars, even before darkness could settle over anything at all. And to understand how such an immense realm of emptiness ever came to be, the story truly begins with the Big Bang, when the universe exploded into existence as a hot, dense soup of particles, energies, and quantum possibilities, as space itself unraveled and stretched at a dizzying pace. It was not perfectly smooth. Instead, tiny fluctuations in the primordial plasma, minute pockets a little denser here, a little thinner there, arose because of random quantum variations imprinted during a period of rapid inflation, and these barely there differences were then amplified as the universe expanded. Gravity tugged on the denser regions, causing them to collapse, gather more matter, and eventually form stars, galaxies, and the vast filaments that now thread the cosmos, while the less dense or underdense regions were left alone, neglected by gravity, and grew steadily emptier as matter flowed towards the competing lights of denser zones. Over billions of years, these underdense patches grew larger, not by blistering eruptions or violent explosions, but by simply being passed over. Voids are absence, not by destruction, but by omission. And as time progressed, the universe's restless motion helped these voids merge, much like bubbles in soapy water, clinging together to form grander, ever more spherical cavities, a process supported by computer simulations and astronomical surveys alike. The Boötes Void, with its nearly perfect roundness and sharp boundaries, is believed to be a product of such mergers, a grand supervoid born from the coalescence of many smaller, more irregular voids that gradually combined, creating a sphere over 330 million light-years wide. This soap bubble model is not merely poetic, but rooted in mathematics, as density fluctuations in the cosmic microwave background predict a universe peppered with voids, filaments, and clusters, each shaped by the push and pull of gravitation from the very beginning. The detailed mapping of the Boötes Void's interior especially the peculiar tube-like trail of galaxies running through its heart. Hints at this history, perhaps remnants of faint filaments that survived the merging, or threads of slightly higher density, where a handful of galaxies could clutch at existence. Yet the rest is just emptiness, a vast cavity where all the ingredients of galaxy formation simply thinned out to insignificance. Astrophysicists have tested this scenario, running elaborate simulations with the lambda-cold dark matter model that governs modern cosmology, finding voids form naturally as the cosmic web evolves. But the Boötes Void still pushes the edge of what randomness can produce. A statistical marvel, not an impossibility, but a rare outcome. Some theorists go even further, wondering if dark matter itself, the invisible glue that governs galaxy formation, is exceptionally scarce in such regions, limiting gravitational pull so drastically that nothing gathers, while others propose that early universe processes like inflation may have generated particularly deep pockets of underdensity, sometimes called rare voids or supervoids. Even more intriguing, some physicists ponder whether exotic mechanisms played a role, such as varying densities of dark energy that accelerate local expansion, or primordial phase transitions that left behind lingering gaps. Speculative ideas abound. What if some yet undiscovered particle field or force shaped the local balance in favor of emptiness? Whatever the catalyst, the emerging picture is that voids are not ruptures or scars left by cosmic cataclysms, but natural features of cosmic geography, as fundamental as mountains and valleys in the landscape of space. The observable universe consists mostly of such emptiness, with galaxies strung along thin filaments and dense clusters, decorating their intersections. And yet the Boötes Void stands out, a monument to the extremes, a larger and cleaner void than predictions usually allow by chance alone. As we explore its boundaries, astronomers continue to debate, is this truly a unique event, or might there be still larger supervoids lurking, their boundaries yet to be mapped, connecting with the Boötes Void through tunnels of emptiness? Or is this the edge of what probability lets us glimpse? Even as the mystery deepens, radio and optical surveys trace the trickle of hydrogen gas, the faint star formation in its lonely galaxies, measuring how stray cosmic flows may feed or starve these outposts. Observing how the void grows, not by devouring, but by letting matter drift further from its heart. This process is mirrored throughout the universe. Wherever density falls below a certain threshold, matter streams away, filaments retract, leaving starkly hollow volumes behind. If gravity is the maker of galaxies, then emptiness is the unmaker, and supervoids like Boötes are its masterpieces. What is revolutionary is that rather than being dead zones, voids become laboratories, pure environments where we can test the subtleties of cosmic expansion, the effects of dark energy, the simplicity of structure formation without complicating crowds. And with each new void discovered, we gather more clues about how randomness, gravity, and time together fashion not only what we see, but what we cannot. So the Boötes Void is more than a vacuum. It is history, physics, fluctuation, and chance laid bare. The grand sum of what it means for a cosmos to grow not just by building, but sometimes, spectacularly, by leaving part of itself untouched. What? In the enigmatic heart of the Boötes Void, theories and mysteries swirl like the faint tendrils of cosmic dust left drifting in the aftermath of creation. And for every attempted explanation, new questions rear their heads, spawning debates that stretch from the smallest quantum fluctuations to the grandest scales of universal architecture. For starters, most astronomers agree on one thing: the Boötes Void is a puzzle that defies simple answers, and its sheer size and sharp boundaries present a challenge even to the most established cosmological models. The leading theory holds that the void was born of merger, a grand coalescence of many smaller voids over billions of years, each formed where the early universe's patchwork of density ripples left certain regions starved of matter. Gradually, these bubbles grew, and like soap suds in a cosmic wash, collided and joined until they shaped an emptiness greater than the sum of its parts. But even this isn't enough to account for everything, especially since the Boötes Void stands out, not just as an underpopulated space, but as one with exceptionally low density. Only about 60 galaxies, where there should be thousands. Some cosmic cartographers suspect that this extreme hollowness hints at even deeper forces at play. Dark energy, the mysterious substance that pushes the universe to expand ever faster, may play a role. It is thought that in some regions, variations or fluctuations of dark energy's pressure could create pockets of accelerated expansion, thinning matter, and leaving behind supervoids. Nearly 68% of the universe is believed to be made of dark energy, a force we can measure but not touch. And in places like Boötes, its effects may linger more strongly. Other theorists turn to the foundational period, just after the Big Bang, proposing that quantum ripples arising during cosmic inflation led to rare pockets where matter was diluted. To truly grasp this, imagine the universe as a balloon speckled with ink. As it expands, the ink spreads, and in certain spots where fewer dots were placed, as the balloon swells, those gaps become ever emptier. Some even suggest that baryon acoustic oscillations, the early density waves that shaped galaxy clusters and voids, may have produced the largest bubbles of nothingness, their echoes detectable in the cosmic microwave background's cold spots. And yet, certain models bristle with uncertainty, arguing that there simply hasn't been enough time since the Big Bang for such a massive void to emerge. By mergers alone, raising the possibility of unknown processes or exotic physics. Here, speculation flowers. What if Boötes is a scar left by a phase transition, an imprint from a time when fields governing the laws of physics shifted, leaving behind a gap where nothing ever solidified? Others ask if the absence of dark matter in the region is unusually severe, since dark matter forms the scaffolding for galaxy creation. A deficit could lead to a structurally clean void, with gravity never enough to collect sufficient material. Some fringe thinkers muse about influences from other universes, impossible to test, but tantalizing, suggesting that maybe an encounter with an object or energy field beyond our cosmos carved this gap. In popular discussions, mysteries proliferate. Some attach the void to ideas like alien megastructures, Dyson spheres, or hidden civilizations, though none of the available evidence supports such scenarios. Instead, the faint tube of surviving galaxies and the smoothness of the void's boundaries point to natural causes, but not all of them purely random. Even now, debates continue about how island galaxies managed to endure in such a hostile environment, why they weren't swept outward into denser regions by gravitational currents. Some recent proposals try to model galaxy motion around the void, suggesting that as superclusters like Hercules form busy highways of matter on the void's rim, the galaxies inside flow with a tranquil orbit, partly insulated by their isolation. Numerical action methods studying isodensity contours show orbits not just away from the void, but occasionally spiraling along its edge, tracing patterns reminiscent of water sliding around a stone. Others invoke fractal geometry, the self-similar patterns that underlie both visible and hidden cosmic structures, postulating that voids like Boötes could be relics of deeper symmetries woven into space and time. Their existence, a fingerprint of primordial laws we have yet to decode. All these avenues point to a universe rich in unanswered questions, where the boundary between structure and absence, gravity and expansion, randomness and destiny gets blurred, and every map of galaxy distribution serves as both a record of what is and a clue to what remains unseen. Perhaps the greatest mystery is not just how emptiness can grow, but whether it signals undiscovered truths about reality itself. Does Boötes Void hint at exotic materials or energies, fundamental constants that vary, or even answers to the nature of dark energy? as we refine simulations with increasingly powerful observatories, probe hydrogen flows, measure expansion rates, and trace the faint whorls of surviving galaxies. Every observation feeds the ongoing search, and for all our efforts, the Boötes Void remains not just an absence, but a question, as profound and impenetrable as the darkness behind its name, leaving us to marvel at how the universe not only builds, but also carves away, leaving behind silent volumes that defy explanation, beckoning us to look deeper. Boötes Void, stepping beyond the monumental emptiness of the Boötes Void. The story of cosmic voids expands into a sprawling tale of absence and contrast that defines the universe at its grandest scale. For Boötes, with its 330 million light-year span, is not alone in being a place so profoundly quiet. It is one among countless other voids, holes, and dark pockets woven throughout the cosmic tapestry, each one with its own dimensions, mysteries, and scientific significance. These voids make up about 80% of the known universe's volume, forming the backdrop against which every galaxy, cluster, and supercluster performs its intricate dance, a vast network where emptiness isn't a flaw, but the essential canvas for structure. Take the Eridanus Supervoid, for example, which rivals Boötes in breadth and intrigue, stretching up to 1 billion light-years across, and possibly connected to the so-called cold spot in the cosmic microwave background. This cold spot is a mysterious chill detected in the relic radiation, marking the universe's birth about 13.8 billion years ago, a patch about 70 microkelvins, cooler than the surrounding 3 Kelvin average. And while some theorize it might be linked to the temperature dip caused by such a vast region of underdensity, where photons lose energy, crossing the sparse expanse, others warn that the evidence does not fully explain the anomaly. Perhaps it's a statistical fluke, or an imprint from quantum fluctuations. Still, Eridanus holds a place in the pantheon of cosmic voids, as a possible key to one of astronomy's lingering puzzles, its fuzzy boundaries blending into surrounding filaments, unlike Boötes' sharp edges. Or consider the Taurus Void, visually large and striking at about 300 million light-years wide, surrounded by walls of galaxies that evoke the image of a titanic bubble pressed against the Perseus, Pisces supercluster. A dense chain of thousands of galaxies, spanning hundreds of millions of light-years. Taurus stands out for its circular symmetry and the dense gatherings that hem it in, making it a textbook example of how voids sculpt a cosmic web. Elsewhere, the KBC Void, also known as the local hole, circles around our own Milky Way, stretching 2 billion light-years across, at the largest estimates, encompassing the local group and perhaps influencing our view of the universe, raising provocative questions about how our observations of cosmic expansion, the so-called Hubble tension, are affected by living inside a subtle region of underdensity, where local expansion rates, measured at 74 kilometers per second per megaparsec, clash with cosmic microwave background predictions of 67. In fact, some researchers suspect that the warped view we have from inside the KBC Void might contribute to these discrepancies. As local voids dilute gravity and accelerate space's stretch, then there are colossal supervoids that dwarf even Boötes in diameter, such as the gigantic void discovered near the constellation Lynx, measured at nearly 1.8 billion light-years across. But unlike Boötes, it lacks the sharpened definition and crisp borders, fading gradually into neighboring filaments and clusters, like the Hercules Corona Borealis Great Wall, a filamentary structure 10 billion light-years long. This difference underscores a subtle truth. Not all voids are alike. Some are fuzzy and elongated, others spherical and stark. Some contain strands of galaxies, like the faint tube in Boötes. Others appear nearly sterile with densities dropping to 1/3 the cosmic average. The uniqueness of Boötes lies in its clarity, its emptiness, with only about 60 galaxies, where thousands should thrive, and the way its boundary is sharply delineated by the surrounding Hercules, Ursa Major, corona borealis, and Shapley superclusters, but collectively, these voids and the filaments that separate them compose the cosmic web, a three-dimensional structure of matter mapped out over billions of years, observed in surveys like the Sloan Digital Sky Survey that has cataloged over 4 million galaxies and simulated by supercomputers, running advanced cosmological codes that recreate the universe's evolution from the Big Bang's quantum seeds. Within this web, most galaxies are found clustered along threads, filaments that can stretch billions of light years, intersecting at nodes of high density, superclusters like Laniakea, which spans 520 million light years and includes our Milky Way, while the intervening spaces are filled with voids, places where matter simply never gathered, perhaps due to primordial underdensities amplified by inflation. What's astonishing is that voids are not just curiosities or anomalies, but essential features predicted by the lambda cold dark matter model, where dark matter, about 27% of the universe's content, provides the gravitational scaffolding for structure, and dark energy, 68%, drives the void's expansion. They emerge naturally from the quantum ripples and inflationary expansion of the universe after the Big Bang, forming not in isolation, but in networks where the absence of matter defines the structure, just as much as presence does. Voids like Boötes serve as cosmic laboratories for studying dark energy, structure formation, and the effects of large-scale expansion. In supervoids, the accelerated stretching of space can be measured more purely, free from interference by crowded masses, revealing expansion rates that help calibrate the lambda parameter at about 0.7. Meanwhile, the paucity of interactions in void galaxies allows astronomers to observe star evolution, gas depletion with hydrogen masses around 3 × 10 to the 9th solar masses, and even galactic morphology in near-pristine conditions as new generations of telescopes, like James Webb peering infrared to spot hidden dwarfs, Euclid mapping billions of galaxies in 3 dimensions, and the Vera Rubin Observatory scanning the southern sky for transient events, extend their reach. The catalog of voids will grow exponentially, mapping not only their sizes and shapes, but the subtle flows of gas and faint glimmers of hard-to-see interlopers. And as detailed simulations improve with projects like Illustris TNG, voids beyond Boötes will take on new meaning, perhaps revealing structures even farther from average, with galaxy counts lower than 60 or sizes surpassing 2 billion light-years. Their boundaries will help calibrate the cosmic expansion rate and test limits of the current models, challenging ideas like modified Newtonian dynamics if voids prove too extreme. In culture and philosophy, voids take on almost mythic significance, places where the universe seems to pause, reflect, or recede, haunting us with awe at their silent grandeur. Astronomers have long mused that if the Milky Way were at the center of Boötes, galactic isolation would have kept humanity from learning of other galaxies until the arrival of powerful radio telescopes in the 1960s, peering out to detect the Andromeda Galaxy's glow after 2.5 million light-years, and in regions like the local void, which surrounds our galactic cluster at about 195 million light-years wide. This gentle underdensity plays a subtle role in shaping not only what we see, but how we measure cosmic truths, pushing the Milky Way towards the denser Virgo supercluster at about 600 kilometers per second as more voids are found. Taurus at 300 million light-years. The giant void, also known as Canes Venatici, at 1.3 billion light-years. The northern local supervoid at 339 million light-years, separating major superclusters like Virgo and Coma. The southern local supervoid at 365 million light-years. The Lows North, 13,788 void at nearly 3 billion light-years, containing over 109,000 galaxies, yet still underdense. The Lozes South, 4,653 at 1.6 billion light-years, and countless others cataloged in lists. From surveys like the B and B Abel voids, or Tully's compilations, each ranging from 456,000 light-years for Tully 1 to over 2 billion for the local hole. They extend the cosmic map, showing that the story of the universe is as much about what is missing as what is present, that emptiness is not a flaw, but a design. And in the cosmic ledger, places like Boötes remind us that the universe balances fullness and silence, connection and solitude, in a dialogue that shapes everything, from the formation of the first stars in dense pockets to the eventual heat death, where voids dominate an ever-expanding cosmos. Looking beyond Boötes, the quest continues into the darker pockets, like the Boötes Void at 130 million light-years, or the Sculptor Void at 163 million light-years, the grand volumes unlit by any cluster or filament, where the next great nothing may be waiting to tell its own story, perhaps linked to cold spots or gamma-ray bursts, and where astronomers and dreamers alike will keep searching, always moving farther into the quiet that helps give the cosmos its voice, probing with upcoming missions like the Nancy Grace Roman Space Telescope to map voids in infrared, or the Square Kilometer Array to trace neutral hydrogen across cosmic history, revealing how these absences evolved from the epoch of reionization, when the first galaxies lit up the Dark Ages, ultimately painting a portrait of a universe where voids are the silent majority, their vastness a testament to the delicate interplay of gravity, expansion, and chance that birthed everything we know, inviting us to wonder if in their depths lie clues to multiverses or parallel realities, brushing against our own, or simply the profound beauty of a cosmos that thrives on contrast, where the spaces between define the stars as much as the stars illuminate the spaces. True. As we draw this cosmic odyssey to a close, the Boötes Void lingers in the mind like a profound silence after a symphony. A vast spherical expanse, roughly 330 million light-years across, cradling just about 60 lonely galaxies, where thousands should flourish, discovered in 1981 by Robert Kirshner and his team through meticulous Redshift surveys that peeled back the veil on the universe's hidden architecture. It stands not as a mere curiosity or a glitch in creation, but as a cornerstone in our quest to unravel the grand design of everything that is and isn't, from its initial unveiling in the constellation Boötes, 700 million light-years from our Milky Way home, to the deeper dives into its sheer scale that swallows over 3,000 Milky Ways end to end and accounts for nearly 0.3% of the observable universe's volume. We've journeyed through its emptiness within, where those sparse islands like the faint spiral MCG +01 -02 -01 5 drift in a tube-shaped filament, their hydrogen disks compact and star formation simmering at rates that stretch gas depletion into billions of years, starved of the mergers and interactions that sculpt galaxies elsewhere, exposing misconceptions that paint it as a black hole's maw or an alien megastructure's shadow, when in truth, it's no Barnard 68 dark nebula blocking light, but a natural underdensity, 100-fold below average, born from primordial quantum ripples amplified by inflation. Then we explored how voids like this form through the coalescence of smaller bubbles in the cosmic foam, gravity pulling matter to denser filaments, while emptiness expands unchecked under dark energy's push, comprising 80% of cosmic volume in a web where filaments hold the galaxies in 20% of the space, delving into theories and mysteries that challenge the lambda cold dark matter model, from varying dark energy densities to phase transitions, leaving scars or even speculative brushes with multiverses, and venturing beyond to kin like the Eridanus Supervoid, linked to the cosmic microwave background's cold spot, the 2 billion light-year KBC void, encompassing our local group, and skewing Hubble tension measurements, the 1.8 billion light-year Lynx void fading fuzzily, the 300 million light-year Taurus void pressed against Perseus, Pisces, the 1.3 billion light-year giant void, in Canes Venatici, and countless others, from the Sloan Digital Sky Survey's catalogs, each a testament to the universe's Swiss cheese nature. Now in reflection, the Boötes Void encapsulates the profound duality of existence. Fullness, defined by absence, structure by void, where its sharp boundaries, against superclusters like Hercules and Ursa Major, highlight the universe's filamentary backbone, a relic of the Big Bang's uneven settling. 13.8 billion years ago, when baryon acoustic oscillations rippled through the plasma, seeding overdensities that became galaxies, and underdensities that ballooned into these supervoids. Its significance ripples outward, serving as a pure laboratory for probing dark energy's acceleration, with expansion rates unhindered by mass offering benchmarks for the lambda parameter at 0.7, helping resolve tensions like the discrepancy between local 74 kilometers per second per megaparsec measurements and cosmic microwave backgrounds 67, while its island galaxies, with lower metallicities, from fewer supernovae and rotations at 256 kilometers per second, reveal evolution in isolation. Compact disks of 3.1 times 10 to the ninth solar masses of hydrogen against 21.5 times 10 to the ninth in stars, a slow simmer without tidal disruptions, challenging us to refine simulations like Illustrist NG that struggle to birth such extremes without tweaks, perhaps hinting at modified gravity or primordial non-Gaussianadities. In inflation, philosophically, it evokes awe at our place in the cosmos. For if humanity dwelled at its heart, telescopes might not have glimpsed Andromeda's glow until the 1960s, fostering myths of a singular universe rather than the 100 billion galaxies in our 93 billion light-year observable patch, underscoring isolation's potential to reshape worldviews, from ancient Greek atomist voids to modern existential echoes. Yet it affirms the cosmological principle's resilience, matter averaging uniform on scales beyond 100 million light-years despite local flukes, and in studying it through advancing eyes like James Webb's infrared hunts for dwarfs, Euclid's three-dimensional maps of billions of galaxies, Vera Rubin's transient scans, or the square-kilometer arrays neutral hydrogen traces from reionization's dark ages, we edge closer to truths about neutrino masses, dark matter deficits, and the universe's topology, flat, curved, or riddled with anomalies brushing parallel realms. The void's tube of survivors, echoing an axis in fractal patterns, whispers of deeper symmetries, perhaps self-similar to the Higgs field's rotational jet, birthing our matter-antimatter twins. But grounded in observation, it reminds that voids are not failures but features, the silent majority claiming space's expanse, their growth diluting matter as dark energy dominates, pointing toward a heat-death future where filaments fray and voids merge into an ever-thinning fabric. Yet this doesn't diminish wonder, it amplifies it, for in Boötes quiet we see the universe's artistry, chaos yielding order, ripples birthing webs, emptiness framing stars like shadows, define light, inviting speculation on uber civilizations, harvesting Dyson spheres in hidden pockets where simulation glitches in code. Though evidence favors natural coalescence, the emotional pull endures, a confrontation with infinity's humility, where light takes 300 million years to cross what we ponder in moments, rendering our 10,000 years of history a blink, yet fueling curiosity that named this great nothing, mapped its edges, and dreams of probes like Voyager, crawling 0.001 light-years in decades, toward such abysses. Ultimately, the Boötes Void isn't an end, but a beginning. A mirror reflecting our drive to fill voids with knowledge, to bridge isolations with science, turning cosmic silence into symphonies of discovery, where every unanswered question, why so empty, how formed, what mysteries lurk, propels us forward, honoring the universe's balance of presence and absence, connection and solitude, and in its vast hush, finding not fear, but the profound beauty of a cosmos that thrives on contrast, beckoning us eternally to explore, to question, and to marvel at the intricate, indifferent elegance that births stars from nothing and nothing from stars, leaving us forever changed, gazing skyward with renewed reverence for the great everything woven through the great nothing.
酒窝酒窝。